Hello everyone, in this video let's discuss how to solve the left factoring problem in compiler design easily. So if you see here, we are having two problems. If we solve two problems, you will be getting the idea how to solve all the problems related to left factoring. First, let's discuss the general format in which the left factoring problem will occur. So if you see A producing alpha beta 1 alpha beta 2, like this it goes on, and it starts with gamma 1 gamma 2 and it's go on. So I will show how in this problem. Now how to convert this one. So we will be converting into two separately. So A producing alpha A dash slash gamma 1 gamma 2, and how many gamma will be there, that much we will be writing. Next here A dash give rise to beta 1 slash beta 2 slash how many beta will be there, that much beta we will be writing. So this is the standardized format in which the left factoring problem will be occurring. So to solve that problem, we will be writing them in these two formats. Now let's go with the first question. What is the first producer? S is the producer which is producing three separate projection. So he is producing three separate projection. First I will write it. S producing IETS slash IETSES slash small letter e. Now you must search for the value of alpha. Next beta 1, beta 2, gamma also you must search. Now I will tell. Alpha means the common value. Alpha means common value. In more than one production, that must be there as a common element. Now if you see here, IETS is in this projection also, IETS is in this projection also. Extra we are having ES in this second projection. If you see more than one projections are having IETS as common element. So this will become the alpha. Now let's find the beta 1 in this projection, beta 2. Next here there is no common element. Here there is no common element in this projection. So it will become the gamma value, gamma 1. Further, I am not having any projection, so I will stop here. Why this became gamma? Because this is not having the common element alpha, so it became gamma. Common element is there, alpha is there. Now I have to find the beta 1 and beta 2. So here IETS complete projection is used as the alpha value. So no beta value is there. So beta 1 value will be equal to epsilon. Epsilon represent null. There is no beta value. Next, IETS is the alpha value. Small letter ES will become the beta 2 value. So beta 2 value will be equal to small letter ES. Now let's convert this form into this form according to this. Here S is there in place of capital letter E. So substitute here. S producing. What is the alpha value? Alpha value is IETS. Next, A dash. Here we are having S. So S dash slash, I must write gamma values. I am having only one gamma value, that is small letter E. Next, S dash producing beta 1 and beta 2. So here we are having only two beta values. Beta 1 value is epsilon and beta 2 value is small letter ES. Now we converted the left factoring into the normal form. So left factoring is converted into the normal form. Now let's go with the second projection. E is producing small letter B. So if you see, this is not in the form of this one. In the generalized format it is not there. So you can tell that this is the final solution and there is nothing to change in E producing B. So this is the final answer. Now let's move with the second question. So you will get the concept more easily. So in second question, first one is A producing small letter AAB slash small letter AA slash small letter A. Now I must find the common element. The two in the more than one projection with maximum alpha value. Maximum alpha. If you see, I can take small letter A, small letter A, small letter A as the common element and assign them the value of alpha. Because small letter A is common in all three projections. But I don't want quantity, I want quality. Means I don't want in the maximum number of element but I need the maximum common element. So small letter AA, small letter AE. So more than one projections are having small letter A and capital letter A, small letter A, capital letter A in their projection. So I need the maximum element. So I took this one as alpha. Now left out is capital letter B, which will be considered as beta 1, which value will be B. Here there is no element left in the second projection. Small letter A and capital letter A both are used as the alpha values. So you can assign beta 2 will be equal to epsilon, that is null. Next, here you are not having any common element, so you can consider small letter A as the gamma value, gamma 1. Further we are not having any projection, so we will stop here. Now convert to these forms. A producing alpha value. What is the alpha value here? Small letter A, capital letter A. Next, A dash slash gamma 1, gamma 2. Here we are having only one gamma value, that is gamma 1, small letter A. Next, A dash producing beta 1, beta 2, like that. So what is the beta 1 value? Capital letter B. Beta 2 value is epsilon. So now we have completed this question. And another question is there, B producing small letter B, capital letter B, small letter B. Let's take it. So what is the question? B producing small letter B, capital letter B slash small letter B. In this, I will find the maximum common element. Small letter B is there, small letter B is there. The common element must be in more than one projection. Yes, it is in the two projection. So you can assign small letter B value as alpha, and here capital letter B will be acting as the beta 1. So beta 1 value will be equal to capital letter B. Here complete small letter B is used as the alpha value. No beta value is left, so you can assign beta 2 value will be equal to epsilon. Now further no projections are there, so gamma value is not there in these projections. So write it in this format. B producing alpha B dash. So alpha value is small letter B, B dash slash. Whether there is any gamma value? No, gamma value is not there. Next, beta dash B dash producing beta 1, beta 2, like that you must write. What is the value of beta 1? Capital letter B. What is the value of beta 2? It is epsilon. So if you see, we have converted these two forms into these two forms using the left factoring. So just keep in mind this generalized format and how you want to convert the forms of the given generalized format. If you have any doubt, please comment below. If you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.